Okay, we're back and we're ready to start talking about Lambda. And Lambda is a PRE measure, a proportional reduction of error measure. And it can be used when at least one of the two variables in the crosstab table is nominal, which means that if one of them is ordinal, you can still use it. And that makes it a pretty powerful statistic. And as we move along, we're going to find some more flexible and more powerful statistics. But Lambda is a nice PRE measure. The formula for lambda, and this might look a little bit familiar because it looks a little bit like our calculation of chi-square. I'll sort of talk through why that is. So here's the symbol for lambda, and it is equal to E1 minus E2 divided by E1. So E1 stands for the number of errors we would make if we didn't have knowledge of the independent variable. So if we only had our dependent variable, this is how many errors would we make by not having that additional information. And then E2 is the number of errors we make when we have knowledge of the independent variable. So if we're able to see how those two variables are contingent or associated with each other. So this should remind you of FO minus FE divided by FE, right? So our observed frequency divided by our expected frequency. So there's some similarity in the logic of what lambda and what chi-square are doing. So lambda is not a chi-square based measure. So we're not going to be calculating chi-square here. We can calculate lambda instead of chi-square, and it gives us this proportional reduction of error. And let's run through an example. Let's say that we want to predict library usage of students. And if we look at, we have uses library often, 90 students. Uses library seldom, we have 110 students. You can probably see that there's a pattern here that you can detect in that these numbers, remember I told you how things will pull towards the edges, they'll pull towards the corners, and you'll end up with a sort of diagonal thing. So these numbers are the larger of the two values. So we have students off campus use the library more than students on campus. And so we can kind of just visually see that there's a pattern here in the data. And that gives us a sense that we are going to do better at predicting whether someone uses the library or not, based on whether they live on or off campus. So E1, remember, is the number of errors that we make without knowledge of the independent variable. So if we did not know, sorry for the typo there, if we did not know whether someone lived on or off campus, right? If the only information that we had was the information that came from this column, right? So if this is all we had, because we don't have this distinction between on and off campus, how many errors would we make by trying to predict whether someone did or did not use the library, right? So if we don't know where someone lives, how would we predict library usage? Our best prediction would be to draw on just this column that we have on the right. So 90 and 110. And those are the totals for library usage for that variable. So our best guess, based on just the information that we have with the number of people who attended the library often and the number of people who attended it seldom, our best prediction would be to say seldom. Does that make sense? Well, think about why that's our best prediction, okay? So if we say that they attend seldom, we're going to be right 110 times. And we're only going to be wrong 90 times. But if we were to predict, if our best prediction was that they attended the library often, we'd be wrong 110 times. So in making the decision, we're literally just going to pick the smallest, right? Or we're going to pick the largest frequency in that column, because that's our best prediction. We're going to be wrong less if we choose this largest frequency than if we choose the other one. So our best guess would be seldom, because that's our largest variable. If we guessed seldom, we'd be wrong 90 times. But if we guessed often, we would have been wrong 110 times, right? So our E1 is equal to 90. That's the number of errors that we will make. So once we make our best prediction, then we're going to report the number of errors that we make. So we're going to make 90 errors if we choose seldom. And that's the smaller number of those two. And that's how you make the decision. So if you have a larger table, you're going to pick you're going to pick the larger number as your best prediction, and then you're going to add up all of the potentially wrong predictions that would happen. So how many times would you be wrong? And you can do this even if you have more than a 2 by 2, because all of those additional rows would be potential mistakes as well, or potential errors in prediction. So that's how we get to our expected number of errors without knowledge of the independent variable. E2 is the number of errors if we have knowledge of the independent variable. Please forgive my typos. If we do know where somebody lives, how many errors would we make? So if we know where somebody lives, if we know they live off campus, we would make fewer errors by choosing often, right? Because we'd be right 65 times and wrong 35. If we knew someone lived on campus, our best guess would be seldom, because we would be right 75 times and wrong 25 times. So for E2, we are going to, so these are our best predictions, right? If somebody lives off campus, our best prediction is that they use the library often. If they live on campus, our best prediction is that they use it seldom. For the calculation of E2, we're going to take all the wrong answers. So all the times that we would be wrong making that prediction, and we're going to add those together. So we have the incorrect prediction totals is our calculation for E2. So we would make 25 errors if someone was off campus and we predicted incorrectly, and we would make 35 errors if someone was off campus and we predicted incorrectly. Okay? So the next stage in the calculation for Lambda is just to plug that 90 that we got from our E1 and the 60 that we got from our E2 calculation into the formula. So E1 was 90, the number of errors that we made if we didn't know the independent variable. E2 is 60, that's the total number of errors we would make in our prediction by knowing the dependent variable, or the independent variable, excuse me. So 90 minus 60 divided by 90 is equal to 0.33. So Lambda is a PRE measure. And what that tells us is that we can interpret it in terms of percentage reduction of error. That's what PRE stands for, proportional reduction or percentage reduction. So Lambda tells us that we make 33% fewer errors in predicting library usage if we know residency. If we know if someone lives on or off campus, we're going to make 33% less errors in our calculation, or in our predictions, excuse me. So there's some additional information here from Statistics How-To on Lambda and the interpretation and calculation of Lambda for you to use as an example, or for you to use as a reference.